Right. Hello, everyone. Today we're going to cover trig ratios and later on Heron's formula if we have time. But first, we'll review last week's homework. So these were the three most missed problems. So we'll start off with this one. What is the length of x in this 45, 45, 90 right triangle? So if you got the answer, go ahead and put it in the chat. Or if you'd just like to take a guess. All right, did anyone get the answer to this question? I'll give you, okay. Kevin says 4 square root 2, and that is correct. So the relationship we learned for 45, 45, 90 right triangles is that the length of the hypotenuse equals the length of a leg times 2. So since the leg is 4, then you multiply, then the length of the hypotenuse is 4 radical 2. And you can also figure this out using Pythagorean theorem because it's an isosceles right triangle. So the side lengths would be 4 and then 4 and then 4 radical 2 if you use Pythagorean theorem.
Okay, if no one has any questions on that, we will move to question number 9, which is the second last question. So find the value of what? So this is a 30, 60, 90 degree triangle, as we can see by the angle measures given. So 30, 60, and then this is a right angle, so 90. So the value of y. So we learned last class about the ratios in a 30, 60, 90 right triangle. But just to remind you, if this is an equilateral triangle, then this would be 60. And then this would be 30, right? And this would equal this. So that would mean that this is x, then this is 2x. Then that would mean, using the Pythagorean theorem, we could find this to be square root of 4x squared minus x squared, which is equal to x radical 3, right? So that means that we have, that means that the ratios of the side lengths are 1 to radical 3, right? So if we rotate this so it aligns with this, we can see that this has to be x, right? This has to be 2x, and then this has to be x radical 3, right? So we can see that x radical 3 is equal to 4 radical 3. So x is equal to 4, right? And then now we know that y is 2x. So we do 4 times 2, and we get that y is equal to 8. So does anyone have any questions about that? Because this was one of the most missed questions. Okay, I'm not seeing any questions. So hopefully you guys would get a question like this next time.
Okay, next problem. What is the length of the short leg of this 30, 60, 90 triangle? So the short leg is this one right here. And as you can see in the relationship that I've drawn, the length of the short leg would be half the length of the hypotenuse. And the question tells us that the hypotenuse is 6. So then the length of the short leg, or like x in this problem, equals 3.
Okay, so we will be going over right triangle terminology. So the hypotenuse, so this is a review from last time. So, okay, the hypotenuse, remember, is the longest side and it's opposite the 90 degree angle, right? And then the opposite side is opposite the reference angle. It doesn't necessarily have to be the shortest side, right? So given a reference angle, then the opposite side is the side opposite it. And then the adjacent side is the leg that is right next to it, but is not the hypotenuse. So adjacent would be next to. So remember that. Okay, so the 3 trigonometric functions. So sine. Sine is just equal to opposite over hypotenuse. So in the triangle to the left, what is the length of the opposite side? So we're given that this is theta or the reference angle. So what is the length of the side opposite to theta? In the chat, type your answer. So remember, opposite means it's opposite. It's the leg opposite that angle. So what is the length of the side opposite? And it's supposed to say triangle to the right, sorry. Okay, I'm not seeing any answers in the chat. I might just call on someone if you aren't putting your answers in the chat. Okay, I shall just call on someone then. Alex, the triangle on the right, it's right here.
I don't see the triangle.
Uh,
I now I see it.
Okay. Okay, so Alex, what is the length of the side side opposite to this reference?
I'm seeing the problem.
It's just asking you what's the opposite side from this angle.
I think it's 3.
Yes, good job. It is 3. So remember, everyone, it's the side opposite. Okay, good job, Alex. So what does sine theta equal? Aniket, do you know the answer? So what does sine of theta equal?
I joined late, so I'm kind of confused what's happening.
Okay. So sine is just opposite over hypotenuse. So sine theta, given a reference angle theta, is just opposite over hypotenuse. So remember, hypotenuse is the longest side, and the opposite side is just the side opposite to the reference angle. So do you know what sine of this angle would be?
3.
Remember, it's opposite over hypotenuse. So 3 is the opposite side, but what is opposite divided by hypotenuse?
Oh yeah, I think I know the answer. It's 3/5.
Right. Good job, Zane. Okay, yeah. So it is 3/5. So sine of theta is 3, which is the opposite over 5, which is the hypotenuse. So hopefully you guys do not have any questions about that. And if you do, feel free to unmute and ask them. But yes, it is 3/5 or 0.6. Okay, cosine. So cosine is equal to adjacent over hypotenuse. So adjacent is, remember, it's the leg next to that angle. So, and then hypotenuse again is just the longest side. So Colin, what is cosine of theta here? Colin.
What?
Okay, so given that cosine is adjacent, or the leg adjacent to the angle divided by hypotenuse, what is cosine of this angle?
So it'd be 4/5. I'm kind of confused.
I understand why it is 4/5.
I'm confused.
Adjacent అంటే
Okay, so remember that, okay, so firstly, adjacent side. Adjacent side is the side that is the leg, or not the hypotenuse, but it's the leg that is next to the angle. So in this figure, we can see that the leg that is next to this angle is 4, right? Because it's not opposite and it's not the hypotenuse. So it must be the adjacent side. So it's 4, right? So we get 4, and then the hypotenuse, right? So 4 divided by the hypotenuse. So the hypotenuse, we can see that the hypotenuse is 5, right? Because that is the longest side length, and that is opposite the 90-degree.
Okay, so then it'd be just okay, I get it.
So yeah, it would be 4/5, which is equal to 0.8. So hopefully no one has any questions about that. Okay, and Colin, I'm gonna call on you again, because just for this one. Okay, so tangent of theta, given that it is opposite over adjacent. So remember, the side opposite this divided by the side adjacent to it.
Then it'd be 3/4.
Yes, good job. So okay, so remember the side opposite to it would be 3, and then the side adjacent to it would be 4, right? So we would get 3/4, which is also equal to 0.75. So good job to everyone who participated. Okay.
All right, now we've just given you a lot of information. So how should you remember all of this? There's a helpful thing that can help that lets you remember that, and that's Socatoa. So basically the letters represent the ratios for each of the trig functions. So sine is opposite over hypotenuse. That's why there's SOH. And then cosine is adjacent over hypotenuse. So that's CAH. And then tangent, TOA, TOA. Okay, so this is something you should write down right now. Make sure you have all of the trig ratios written down. You can write down Socatoa or just say it to yourself a few times.
Okay, so now we're going to be doing a Desmos. Hopefully you all have that written down. And okay, so you yeah, okay. So you should be seeing my screen. It's loading. And okay.
Yeah, okay. I assigned a class. So I put it in the chat. You can go to student.desmos.com and then enter in the code 6VNJAY.
What's the code again?
It's in the chat. So it's yeah.
Like, do we sign in with the like school account or something?
You can use any account that you wish to, so long as
So what do we do here?
so make sure, okay, so go to desmos.com.
Yeah, I'm already there and I already signed in.
Okay, then you should be seeing problems. It should the code for it should be 6VNJAY.
And you said we can use any account?
Yes, you should be able to.
How do you write? Like, how do you answer?
All right, don't move yet. Just give everyone a chance to join and then we'll let you know. Okay. Just stay on the first slide for now.
So you should see this page and then you should sign in and then you should and then you should see this.
Excuse me.
Yeah.
Yep.
When I logged in with my Google and I found that there was a code that I could use. I pasted the code there and it's not working.
Okay.
Things you copy on Zoom won't work on Google.
How come it works for me?
I'm going to put something else in the chat that you can use to join. So try clicking that link and seeing if logging in there works. Okay, so if you're on the Desmos, you can go ahead and move through the slides. So basically read the information on them and answer the questions. And once, so you are free to move anywhere between like slide 1 and 19. And then after that, just stop. Okay, if you have any questions at any point, you can ask us.
I have a question. A triangle should add up to 180 degrees, right?
Yeah,
But then on here, it doesn't add up to 180.
does it not?
No.
Which
Excuse me,
slide?
what do I do on the first slide?
Slide number 3.
Just answer the, on the first slide. On the first slide, you don't have to do anything. If there's not a question, you can just read everything and then move on.
Yeah, like it adds up to something close to 180, but it's not 180.
I guess it's because like a rounding, or actually, no, it just makes sense. Try dragging the points around and seeing if that changes anything.
Oh yeah, that does change things.
I just got
Oh yeah,
170.
now it adds up to 180, but
Yeah, it seems a bit weird. Don't pay too much attention. Just know that it's 180. Maybe it's trying to trick you guys.
Okay, so to solve for x, so we're trying to solve for x. So we know sine 36, right? So so we know sine 36 is equal to opposite over hypotenuse, right? So sine 36 is 14 over x. So that means to find x, we would do x is equal to, and then we divide. So firstly, to get x on one side, we need to multiply both sides by x. So we get x times sine of 36 is equal to 14. And then we divide both sides by sine 46, so sine 36. And then, so sine 36 divided by sine 36 is just 1, so we get 1x on the left side. And then we get 14 over sine 36, right? So, okay, let me just, okay, I think this is in radians and not degrees. Sorry. Okay, 14 over sine 36 should not be 14. Let me just see how to change that. Okay, wait. I'm just gonna do it on Desmos on a different calculator. So we do 14 divided by sine 36, right? And make sure we're in degrees, right? So we do settings, and then we do down here, we do degrees, and we get 23.818 is approximately our answer. So we have to round to the nearest hundred. So we do 23.82 because 23.818 rounds to that. And then we get that as our answer. So the answer is 23.82.
So so basically it'd be 14 over the sine.
Yeah, 14 over sine 36 would be.
Okay.
I'm confused on question 19.
Okay. Oh, wait, give me a second. Okay, so the question,
I believe it's tan.
okay, so we're trying to solve for x given 36, and we have 14 over x. So what trigonometric function uses both the opposite side and the hypotenuse? So answer.
So is it sin?
Yeah, it's sine. So we would use sine theta for this.
Okay, thank you.
You're welcome. Okay, so I'm just going to explain the first few problems just so, yeah, because you guys seem to be done with those. So this just shows what sine is, right? So sine is an operation that we do to an angle to get the ratio of opposite to hypotenuse. So yes, and we can also use it to get the reference angle if we do the reversing. So okay, so now you try. So what is the sine of angle C? So this is angle C, and remember sine is opposite, so 4 over hypotenuse, which is 5. So we get 4 over 5 as our answer. So that is sine C. And then, so what is cosine of angle C? So cosine is adjacent over hypotenuse. So remember, adjacent is 3 and hypotenuse is 5. So that means cosine of C is 3 over 5 or 0.6. And now what is tangent of angle C? Okay, yeah, someone raised their hand. What's your question?
I have a question. So like when you're just solving with when you're given all 3 angles, but you're only given one side, how do you solve that?
Okay, so let me just draw it out. So okay, so let's say we have this triangle. Okay, that is not a good triangle. So given that this is the right triangle, so remember it has to be a right triangle, given the knowledge that we have right now for us to be able to solve. So if this is a right triangle, and say we're given that this is 6 and this is 3, and we would need to be given more than two angles, because if this is, well, we don't, but if we're given like one side, we'd need to be given more than 2 angles.
Excuse me?
Yeah, go ahead.
I understand that, but how do you do it with when you're only given one side? Like
Okay.
take off the 3.
Okay, so say we're given this and so we need to be given 2 angles. The fact that it's 90 degrees and one of the angles, or we'd need to be given both of these angles so we know that this is a right triangle, right? But say we're given that this is a 90-degree angle and this is a 30-degree angle. So that would mean that, so we know that this is 30 degrees and this is 90 degrees. So therefore this must be 60 degrees. So we can either use sine or cosine, right? Or yeah, sine or cosine. So let's take this 30-degree angle, right? So we so we can do, and say we're trying to find both these sides, okay? So 30, and then I'm just gonna label these X and Y. So sorry. So, or actually, let's say we take 30 degrees, right? So we can do sine of 30 degrees is equal to, and then we know that sine is opposite or y over hypotenuse, right? Which is 6. And remember, well, not remember, but when you plug this into a calculator, you would do y is equal to sine of 30 times 6, right? Because you're multiplying both sides by 6 to get y, right? So 6 times sine of 30, and you'll get your answer for this side, which will be 3 radical 3, right? or something, and it'll round to somewhere around 4, right? And then we are given this side, and then x, right? So we aren't given this side, but we're trying to find it. So we would do cosine of 30 is equal to x over 6, right? Because adjacent over hypotenuse. So we do the same thing. We multiply cosine of 30 times 6, and we get 2. So 2 is equal, oh wait, okay, wait, sorry. We get 3, right? So we get 3 is equal to this side. We get 6 is this side, and we get 3 radical 3 is this side. So hopefully that answers your question.
Okay, so on problem 21, would the answer be number 3? With 3?
Okay, so what you would do is you would do, okay, find the length of AB, right? So you would do, so you'd know this, right? So we're trying to find, so what trigonometric ratio is equal to AB, is equal to adjacent and has adjacent and hypotenuse. We know that's cosine. So cosine of 39 degrees is equal to, and then question mark over 11.66. So we multiply both sides by 11.66, and we get 11.66 is equal to question mark, right? And that is not in degrees. So remember, this is in degrees. So we get 9.0615. So 9.06 would be our answer because it rounds.
I understand what I did wrong.
Okay, okay. Remember that the calculator here is not in degrees, it's in radians. So you will get the wrong answer if you just immediately plug it in right here. So yeah, yes.
But then how do we go to the degree, the graphing calculator?
You could just go to desmos.com/calculator and then just do degrees. However, if you do use Desmos for math operations, it would probably just be easier to use the actual calculator. So, wait. Okay, resources, okay, math tools, sorry. Scientific calculator would probably be easiest to use for this. So, okay, I'm just gonna put the link to this in the chat so that everyone can access it easily. So yeah, hopefully that helps. So you can do your math in there. Yeah. Okay, so back to explaining these problems. So tangent of angle C, remember tangent is adjacent over hypotenuse, sorry, it's opposite over adjacent. So we would get opposite, which is 3 over 4, which is adjacent. So we get 3 over 4, which is our answer for that. And then just make sure you put how well you understand this. And if you want to say more, say more. Okay, so we did this problem. So it would be sine that we would use. Then for this one, 23.82 is our answer, and then 9.06 is our answer for that. So
Okay, so for number 22, I guess I could take a turn explaining this one. So we're trying to find the length of leg AC. And so the reference angle we're given is angle B, which is 42 degrees. So we need to figure out what AC is in relation to angle B, and it is the opposite side. So now what do we know? We know the length of the hypotenuse, and we're trying to find the length of the opposite side. So we have to figure out which trig value relates to the opposite and the hypotenuse, and that would again be sine. So then we have to set up an equation that represents this, and we can set leg AC equal to some variable. So like just we can say x, and then our equation would be sine 42 equals opposite divided by hypotenuse, or x divided by 8.82. And from here, we need to isolate x on one side before we can put it into our calculator to solve it. So you would multiply both sides by 8.82. And then you get 8.82 times sine 42 equals x. Now you can use like the calculator Ishani link, you could use your own calculator. But anyway, the answer you should get is 5.9 if you round, 5.90. Okay, and I don't think you guys have gotten to 23 through 25. So you can go ahead and go through those yourself. 3 to 25. Okay, if anyone else wants to unmute and say like how they're doing. Or,
Well, doesn't it just say,
I need help on that one too. I need help on that one too.
okay. Yeah, go ahead, Colin.
never mind.
Okay, so based on what Ishani typed in the box, which trig ratio uses opposite and adjacent? Type your answer in the chat of Zoom. Yeah, you guys are correct. So tangent. So we need to use tangent to solve this problem. And so once you figure out which you should use, sine, cosine, or tangent, you do that of the reference angle. So we're going to find the tangent of 50 degrees because that's the reference angle here. And then now what is tangent? Tangent is opposite over adjacent. Remember, Socatoa. So we know that the adjacent side of this triangle relative to 50 degrees is 17.6. And then the side we're trying to find is the opposite side. So we're going to call that x because we don't know what it is, right? And now you have your equation. Oh, interesting. Okay, so you should try to isolate x on one side because once you've isolated x, then you can put it into your calculator. So to isolate x, we need to multiply both sides by 17.6. And then that gets us 17.6 times tangent 50 equals x. Okay. And now you should go to a calculator, type that in. Tan 50 times 17.6. And then your answer, it should be 20.97.
Wait, does the tan and the parentheses make a difference in your answer?
Yeah, it would be like different from sine 50 or cosine 50.
Okay, so I only entered 50 times 17.6.
Oh yeah, it would definitely be different. Because 50 is like the angle measure. You have to find tan, which is like the ratio of the opposite to the adjacent.
Yeah, remember that whatever you're putting in the parentheses of the tan function or the tangent function is not being multiplied by some like value called tan. It's being, they're finding the opposite over adjacent, right? So if you put 17.6 times 50 in that parentheses, in those parentheses, you're gonna get a different answer than tangent 50 closed quantity times 17.6. Right, because tangent is a function, like it's not multiplying, it's doing different math than just multiplying, right? So remember, what's in the parentheses is having an operation done to it. It's, yeah, and the operation is not multiplication. Okay, so we're going to give you time to do 24 and 25. Or actually, we're just going to go over it right now. Okay, so I'm going to do 24. So Snake the snake wants to know how long he is, but everyone he asks just runs away. He crawls next to a red triangle. Help him figure out his length. So we know that, so Snake, okay, so we have this angle, right? So we have the adjacent, right? Or we're trying to find the adjacent, and we know the hypotenuse. So in the chat, what's it called? What trig function has both adjacent and opposite? Okay, so what? Okay. Remember, sorry, not adjacent and opposite, adjacent and hypotenuse. Okay, it is cosine. So adjacent over hypotenuse is, so we would have adjacent over hypotenuse, right? Is equal to cosine. And remember, we're finding the cosine of the reference angle, which is 37. So we do cosine of 37. And so we know that we're trying to find the adjacent, right? But we know what the hypotenuse is. The hypotenuse, okay, so the hypotenuse is just equal to 22. So we do adjacent over 22 is equal to cosine. Okay, let me rewrite that. So adjacent over 22 is equal to cosine of 37 degrees. So we multiply both sides by 27, right? So we get cosine of 37 times 22. Sorry, I'm misspeaking. I misspoke. So times 22 on both sides. The 22s here cancel out, so we're left with adjacent, or the side we're trying to find, is cosine 37 times 22. So now we can just go to a calculator, and we get cosine of 37 times 22, and you should get 17.5699, or 17.57. So our answer would be like A, or the first choice. So does anyone have any questions on that? Okay. Does anyone not have questions? If you don't have questions, but I don't have questions, or something to that extent, in the chat.
I have a question.
Okay, go ahead.
So you're doing basically the same thing for sine, cosine, and tangent, right?
What do you mean by that?
Like same, kind of like the same formula depending on what numbers you get, right?
Right. So we do the same operations because those are
Yeah.
but the actual sine, cosine, and tangent vary with what they do. But outside of that, like we multiply it by whatever. So we multiply it or divide it depending on the equation we set up.
So it's just kind of like a label, right? Depending on what sides you use. Okay.
All right. So for 25, let's go step by step through how we would set up the equation for this. So in the chat, type what the reference angle is here. I'm going to ask you guys to type lots of things in the chat, so be ready. Yeah, that's correct. 47 degrees is the reference angle here. And so the length that's given is the length of the hypotenuse, which is 150 feet. And we're trying to find how high the kite is from the ground. So what side is that in relation to 47? Is it the adjacent side or is it the opposite side? Type your answer in the chat. The height of the kite from the ground. All right, be careful. Okay, so which line of that triangle is the height of the kite from the ground? Is it the one? So the adjacent side would be like the distance from you to, it would be like the horizontal line on the ground. And then the vertical line is how high the kite is off the ground. So yeah, you're changing your answer to opposite. The opposite side is correct. So we know the hypotenuse and we're trying to find the opposite side of this triangle. Now, based off of that, which trig function should we use? Remember, Socatoa. All right, type your answer in the chat. We know the hypotenuse, we're trying to find the opposite side. So which trig function relates to the opposite and the hypotenuse? Yeah, exactly. The right answer is sine. So now, so basically we're going to take the sine of the reference angle. So sine 47 equals, and now what should be on the opposite side of that equation? we know that sine is opposite over hypotenuse. So sine 47 x. Yeah, good job. So the answer should be sine 47 equals x over 150. Step is to isolate x on one side. So we're going to multiply both sides by 150 in order to do that. And then we get 150 times sine 47 equals x. Okay, so now that we have that equation, type it into a calculator on your own. So I just want to make sure you guys know how to type it into a calculator. So type sine 47 times 150 into your calculator, and then type in the chat what you get. You can round it to the hundredths place. Okay, yes, the answer here is 109.7. All right, does anyone have questions before we move on from the Desmos?
Okay, if no one has any questions, we can move on. So in geometry problems, you always want to draw a diagram. Yolanda, are we doing these or are we going to skip to Heron's point?
Yeah, I think this is more important.
So angle of elevation and angle of depression. So an angle of elevation is when you are at a height, right? And you're looking upwards. So think about it as like, say you're standing at like the bottom of a cliff and you look up. The angle that you look up is the angle of elevation. And then angle of depression is where you look down. So think about like, so it's your line of sight. So below that, how many degrees below that? So think about if you're like at the top of that cliff and you're looking down, how many degrees from like straight forward are you looking down? And that is what angle of depression and angle of elevation are. Okay, so an example. So you're standing 50 meters from a hot air balloon that is about to take off. The angle of elevation to the top of the balloon is 28 degrees. Find the height of the balloon to the nearest integer. So this is an example, so I'm gonna do it. So you're standing 50 meters from a hot air balloon, right? So here's 50, here's, and then here's you, or yes, this is you. And then this is the hot air balloon. So I'm just gonna put balloon, right? And okay, and the height, right? So this is the height, this is how far away you are from it that is about to take off. The angle of elevation to the top of the balloon is 28 degrees, right? So this angle, so remember when we draw a diagram, we have to label the angle. So the angle of elevation. So angle of elevation is if our line of sight is this, then how much we're looking up, right? So this would be 28 degrees, right? So this is 28 degrees. So find the height of the balloon to the nearest integer. So remember this whole thing is the balloon, right? So this is like the balloon, right? This whole thing is the balloon. Right, so find the height of the balloon to the nearest integer. So we know that this will be a right triangle, and that's because when you're given like things like this, it will always be a right triangle because we're measuring like, I don't know how to explain why it's a right triangle, but it is, right? So we now have a right triangle with a base of 50 and this degree of 28, right? So find the height of the balloon. So the height of the balloon is opposite, right? So that means we're gonna do opposite and adjacent. So in the chat, what okay, so in the chat, what trigonometric function uses opposite and adjacent? Okay, yes, so it is tangent, right? So we do tangent of, okay, tangent of, and then the reference angle is 28 degrees, right? So tangent of 28 degrees is equal to opposite over adjacent, right? So opposite is what we're trying to find. So let's just name it x, right? You could name it any variable, but let's just name it x over and then 50, right? Because that is the adjacent. So opposite over adjacent is tangent of x, right? Or tangent of any value. So opposite is x and adjacent is 50. So we multiply both sides by 50 and we get 50 times tangent of 28 is equal to x, right? So now we have to multiply this out. So we do 50, so you can type this into your calculator. 50 times tangent of 28 is approximately 27 because it's 26.5, 58547158, right? So we get our answer as 27. So that means the height of the balloon is approximately 27 feet. So does anyone have any questions on that?
I don't understand like anything about the whole question.
Okay, I need you to be more specific. Like, where do you stop understanding?
Like, I know what you do for 50 times tan in parentheses 28 degrees, but then I don't get what you do after that.
Okay, so you just use your calculator to calculate the value. So you do okay, so okay, let me just okay, so 50 times tangent of 28, we all get that. So okay, so we get that 50 times tangent of 28. So what you would just do is 50 times tangent of 28. Right, you're just using your calculator at this point. You're not actually doing anything else. You're not actually doing it. So it's 26.5854, and that rounds to 27, which is how we get this value. So does that answer your question?
Yeah.
Okay. Okay, so if no one else has any questions, we will move on. Okay, and just a thing to note, so you do need to draw the diagram. Like eventually you might get to a point where you don't need to. However, to prevent any mistakes, you always want to draw the diagram, right? Even if you don't need it, just so you know what you're solving and how you're solving it, right? So make sure you don't do like wrong drawings. So wrong drawings would be where you forget what like the angle of elevation is, right? This would be if you thought 28 degrees was the angle of depression, but it's not, right? And then 50 over here would be if you thought that it was from here, from where you're standing to the top. Usually when it says your distance from something, it is the horizontal distance. So unless they specify otherwise, unless they say the exact distance from you to the person at like the top of the cliff is 100 or something, right? It's always going to be the horizontal distance that you're given, right? So yeah, make sure you draw the right diagram.
Okay, so now we're going to give you some opportunity to practice drawing the diagrams. So you can click the link in the chat, and we're just going to cover like one practice. So the first one. Okay, so once you're on the Jamboard, you'll see the question is, a man is sitting in a boat 175 feet from the base of a vertical cliff. If the angle of elevation between him and the top of the cliff is 42 degrees, find the height of the cliff. Okay, so then you can go to the next page or the second page or the third page, pick an empty box. try your best. Just try your best to, and you can just make a guess at what triangle you draw. And then we'll explain in about in 2 minutes. So at 4:21.
Oh, the Jamboards are working for me.
Can you say that again?
The Jamboard is not working for me.
Okay, so if it's not working, just get a piece of paper and you can practice drawing the picture yourself.
Make sure you aren't logged into your JCPS account because that will mean you're unable to access it, right? Make sure you're logged into a personal email. It can be your parents' email. It can be any email, just so long as it's not a J.
Okay. I am logged into my parents' email.
Okay, yeah, sometimes Jamboard is just laggy, so you can just do it on a piece of paper.
What are the measurements?
Did you just ask the question? Because I didn't catch what you said.
What are the measurements for like the
Oh, okay,
triangle?
sorry about that. So a man is sitting in a boat 175 feet from the base of a vertical cliff. And then the angle of elevation between him and the top of the cliff is 42 degrees. I can type this in the chat.
I got really laggy that my screen completely froze.
Okay, it's not loading for me either. So I think it just might be a problem, right? So the question is in the chat. I can put it on my screen, right?
And my browser crashed. That's
Oh,
great.
no. All right, just try doing it on a piece of paper. We'll give like 1 more minute, but we do have to move on soon because of time.
Oh, it works now.
Okay, excellent.
Okay. So Yolanda will share the screen now because mine isn't plugged.
All right, so it is 4:22. So if you're still working, keep on going. Oh, great. As soon as you share, the whole Jamboard just does not work at all. Let's see. Okay, it's still working. So I'm going to go ahead and demonstrate drawing this. Okay, so the man is sitting in a boat 175 feet from the base of the vertical cliff. So let's draw the vertical cliff like this. And then he's 175 feet away from the vertical cliff. So that's this length right here. And then the angle of elevation, sorry, that line is a bit curved, between him and the top of the cliff is 42 degrees. So we write that here because imagine him looking up at the cliff, okay? That's angle of elevation. So this is the problem we have here. And then now if we were to try to solve this or just define the height of the cliff, we would assign this x. And then we would use a trigonometric ratio. Okay, so it looks like a lot of you guys got your pictures right. Make sure for 42, make sure you write that like as an angle, not as a side length, because it's the angle of elevation. So that should be right here. And now,
It's still working for me, but then my screen black and white.
I did not catch that. Can you repeat yourself?
I started to like draw mine, but my screen gets going black and white. Like, it was the last one.
Yeah, don't worry about it. Okay, as long as you can see the drawing I have here. All right, so we're going to go over solving this problem really quickly. So you're trying to find the height of the cliff. And so you know the adjacent side and the opposite side to your reference angle, which is 42 degrees. So with that information, what trigonometric function should you use for this problem? Sine, cosine, or tangent? Type your answer in the chat.
I just lost my edit access. Oh, never mind. It just kicked me out.
Don't worry about it. All you need to do is look at my screen, okay? So we know the adjacent side, and we're trying to find the opposite side. Which trigonometric function relates the opposite side to the adjacent side? Yeah, exactly, tangent. So then the equation we would set up here is the tangent of the reference angle, tan 42, equals opposite over adjacent. So opposite is x, adjacent is 175. Then you multiply both sides by 175 to isolate x on one side. And then x equals 175 times the tangent of 42. So if you want, you can type that into your calculator to figure out what the actual height of the cliff is. Okay. So we're going to go to this.
Like for the equation, tan 42 and something.
Yeah. So the answer is around 157.57 for the height of the cliff.
Yeah, I got it. Thanks.
Okay. So I don't think we really have time to cover Heron's formula. Ashani, unless you want to do it really quickly.
I don't think we'll have time to cover it.
So we might as well just practice drawing another problem. So move to slide 6 in the Jamboard, where it's this one. Oh, oops. Kelly is flying a kite to which the angle of elevation is 70 degrees, and the string on the kite is 65 meters long. So how you need to find how far the kite is above the ground. Okay, so same thing as last time. You can pick the boxes on slide 7 to draw a picture in that represents this problem. Now make sure you know where the string of the kite is. Colin, I love that you drew the person. That's amazing. But just in math, if you're doing this in an actual math situation, probably not a good idea. It's perfectly fine here though.
Probably wouldn't be a good idea.
Yeah. Hey, you can even draw the kite if you want. All right, so the string of the kite is 65 meters. So be careful where you place the string. Think about it. If you're flying a kite, you're over here, the kite's over there. Where's the string? Okay. I think it, good job. You put the string in the right place. So the string would be the hypotenuse of this triangle. And I know a lot of you guys are just putting the string in, but we're almost out of time for this class. So yeah, good. And then where would you put the 70 degrees? Where would you put the angle of elevation? Go ahead and draw that on your pictures, everyone. All right, good. You have a question mark representing the unknown, which is the how far the kite is above the ground. And yeah, Colin, you're correct. So the reference angle is that 70 degrees right there as the angle of elevation. And so if you were solving this problem, you would find the trigonometric function that relates the opposite side to the hypotenuse, because this side right here, what you're trying to find, is opposite to 70 degrees. And so then that would be sine 70 equals question mark over 65. Okay, does anyone have any questions? It is 4:30 now. So you are free to go.
Also, wait,
yeah.
just a thing. The answer to that last question was around 61.08. So yeah. Good job. to
Homework
everyone.
will be posted in about 5 minutes. There are some problems that have to be changed since we didn't get through all of the stuff. So yeah, just be on the lookout for that. Great job, everyone.
Yeah, good job.
Bye.
Bye.